Hello and welcome to another in the Foundation series for the RSGB Foundation examination from the Cornish Radio Amateur Club. And today we're looking at operating practices and procedures. And a lot of this information is taken from the advanced book, which is available from the RSGB. And I would suggest that everybody gets one of those because it's essential reading for the foundation examination. If you want to do some further study, you can have a look at one of our videos there. This is operating techniques, which is in the advanced series on this same channel. So let's have a look, as usual, at the syllabus. So the syllabus, section 8A, operating practices and procedures. We need to understand why one should listen before calling and then ask if the frequency is in use. Recall how to make a CQ call. Understand the need to move off the calling channel, brackets when on VHF or UHF, once contact is established. Recall the phonetic alphabet. Understand that the transmission of music and the use of offensive or threatening language whilst on the air are unacceptable in amateur radio. And then continuing on with section A, understand how to respond to music or inappropriate language overheard or received from other stations. Recognize the advisability and common practice of keeping a log and the items recorded. This item, 8A7, will not be examined, and for that reason I haven't included it in this video, but there's plenty online and also in the Foundation License Now book. So operating through a repeater. Recall that repeaters are mainly intended to extend the range of mobile stations. Recall how to use a repeater and understand the need for an access tone or CT/CSS and frequency offset. And then band plans. Recall why band plans are used. Identify items on a published band plan, e.g. calling frequencies and recommended modes. And then it says see note 4. And note 4 says band plans are produced and revised by the International Amateur Radio Union, IARU, in conjunction with the National Societies, which is the RSGB for UK. Consequently, the band plan used for examination purposes and relevant questions in the bank will from time to time lag behind the current IARU plans. So what they're saying is that they'll give you a handout, and you can download the same handout. It's called EX307, and the questions that you'll be presented with in the examination, the correct answer can be found on EX307, and it's just a question of looking it up. But they're saying that because the questions and the publication of EX307 are fairly static, they're not revised as often as the band plans are revised, then the information may be out of date. So you shouldn't use EX307 as a reference for actually operating when you get your license. Just use it for showing understanding of what band plans are and for answering the questions. So 8D, connecting microphones and other audio sources to the transmitter. Recall that connecting anything other than the supplied microphone, e.g. packet radio TNCs, that's terminal node controller, to the transmitter requires correct operation of the PTT line, that's push to talk, that's the button on the side of the microphone if you like, and correct audio signal levels. And AT and AF are competence in making radio contacts and connecting a TX-RX, a transceiver. So this part of the syllabus is carried out as a practical assessment by registered assessors and may be part of the training course. So for those in the Cornish Radio Amateur Club, we will have already covered that, and you will have your signed off sheets already done by the time you get into the examination. For people watching from outside, this is something that you need to take up with your local club and get a registered assessor to sign off these practical tasks. And this isn't covered in this video. We may produce a video covering the process that we use in the Cornish Radio Amateur Club in the future. So let's start going through those syllabus items. And the first thing then is listen, listen, listen. And here, illustratively, we have F3ABC talking to M6XYZ and using the sky wave, and you'll recall from propagation, that means he's using HF. So this is over the horizon communication between a French station on the left and M6XYZ. And G4PGD, also in the UK, and same as M6XYZ, can hear M6XYZ because he's close by and he can listen through ground wave. Now, if F3ABC is talking and M6XYZ is listening, then G4PGD cannot hear F3ABC, and he might assume that the frequency is therefore not in use. So he can hear M6ABC if he is talking, but let's assume for the minute that F3ABC is having a fairly lengthy over. So if he jumps straight in and says CQ, 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 this is G4PGD, CQ, 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 this is G4PGD, CQ, 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 this is G4PGD. That animation is meant to illustrate that he's blocking out F3ABC such that the station M6XYZ cannot hear the conversation and would be consequently annoyed. So what he should have done is he should have listened first, and if he doesn't hear anything, he should ask, and he should just simply say, G4PGD, is this frequency in use? Rather than having a lengthy CQ, CQ, CQ statement. And the answer then can come back from M6XYZ, affirmative, frequency in use, thank you. And although there will have been a small interruption to M6XYZ's conversation with F3ABC, it won't be nearly as bad as if G4PGD had sent out a lengthy CQ. That's not the only circumstance in which this sort of thing happens. It can also happen not only on HF, but on VHF or UHF. Here we illustrate M6ABC talking to M0XYZ, and G4PGD cannot hear M0XYZ because M0XYZ is in the shadow of the hill. But he is line of sight to M6ABC, and he could hear M6ABC if M6ABC were talking. So there's the diagram then of the VHF or UHF paths that are available. So once again, first of all, he should ask if the frequency is in use, and that gives the opportunity for M6ABC to respond, yes, the frequency is in use, and then G4PGD can then make other arrangements. So when you have checked, so first check the frequency, whether the frequency is in use. If it is not, make a CQ call. And a CQ call may be something like this. And you'll find that I've taken this directly from Foundation License Now from the RSGB. So station on the left would say CQ, 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 CQ. This is Mike 3 Alpha Bravo Charlie calling CQ. And he might get the response, M3ABC, this is Papa Alpha 1, X-ray Yankee Zulu, Papa Alpha 1, X-ray Yankee Zulu. So he's had a response, and then he might say, Papa Alpha 1, X-ray Yankee Zulu, good evening, name here is Peter, location Southampton, over. and then the Dutch station would say, Mike 3, Alpha Bravo Charlie, good evening, Peter, name is Jan in Hilversum, your report is 5959, over. And then the final part of the conversation, the final over, might say, okay, Jan, your report is 5 and 7, 57, good signal. So we can see there is no particular format that has to be adhered to, but this would be a very common format and understood easily by both sides and other people listening. And a key part of that QSO, as it is called, that contact, is the signal report. And here then is the signal report. It can be either 2 or 3 figures. It's readability, strength, and, if you're using Morse, tone. The readability is between 1 and 5, the strength is between 1 and 9, and then the tone is between 1 and 9. So in the previous example, we had 5-7, 57, we had 5-9, 59. If we were using CW or Morse, we might have 599, and so an additional figure is added to represent the tone, how pure the tone sounds to the person listening to it. Now, if you look on the look in the Foundation Now book, on the inside cover, you will find useful items for a Foundation license holder. There are some commonly used abbreviations. There is a list of the phonetic alphabet and the RST code for reporting signal reception. And so if you turn to the inside cover there, you can see what the numbers mean. You don't have to learn those, you just have to know the basic format of the readability, strength and tone, and realize that a low number would mean readability 1, for example, would be not very readable or faint, unreadable, and then 5 would be totally readable. So the higher the number, the better it is. Also, in the syllabus, you do need to know the phonetic alphabet. And here we have the phonetic alphabet, and that is also on the inside of the cover of the Advanced Now book. On the screen here, I've put down A to Z and the code word, for example, Alpha, Bravo, Charlie, Delta. I've also included the Morse, but that's just for information only. You do not need to know the Morse code. And on the right, in the right column, the phonic, how you would actually say it. So, for example, uniform is uniform, and that shows you perhaps a good way to extend the pronunciation of it to make it clear over the radio. So the RST and phonetic alphabet guide is on the inside rear cover of Advanced Now. So, making a CQ call, first check if the frequency is in use, and you may well make it on the calling frequency. So if you do, and you make a CQ call on the calling frequency, perhaps on VHF on 2 meters, and you have a long rambling conversation using the calling channel, instead of QSY to working frequency after the contact is made, you will hold the channel up for other people. QSY is one of those abbreviations that you need to learn, not for this examination, but as you start to operate the radios, it means change frequency. So if I said QSY 145,500, that would mean change frequency to 145,500. So that's not testable, but it's a useful bit of information. So here we have then, somebody has made a call on the calling channel, and instead of QSYing to a working channel, they've stayed on the calling channel. And so this means somebody else in the vicinity can't make a general call on the calling channel because it's busy. and that there is a cause of frustration. One of the syllabus items says, understand that the transmission of music and the use of offensive or threatening language whilst on the air are unacceptable in amateur radio. So if you hear inappropriate language or music or such like, the correct course of action is to totally ignore it and such that the perpetrator is unaware that he has been heard. And this is an item that does come up in the tests occasionally. What should you do? Should you A, inform the person that it's unacceptable, B, report him, C, etc. So the answer there on the screen is a commonly used answer there. Just simply ignore it. And I think this has been found as the best way of discouraging such behaviour. Right, let's move on to repeaters. Now, if you have VHF or UHF, you will recall from propagation that tends to be only slightly better than line of sight. And repeaters are for mobile use mainly, but a lot of people use them from fixed locations. And so here we have an example then of a hill with a repeater on the top, and it allows station A, whose normal point-to-point or simplex coverage would be the yellow circle around station A, to talk to the van shown as B, which is on the other side of the hill. And because they don't have overlapping simplex coverage, they wouldn't normally be able to communicate with each other. So here's a little bit of how that repeater works. Here in Cornwall, we have GB3NC, that's the identification of our repeater, and it started as NC for North Cornwall, and it's located near St Austell. And the receiver in St Austell is listening on 145.125, and the transmitter connected to that receiver transmits on 145.725. In other words, the transmit is 600 kilohertz more than the receive. Or, putting it another way, the receive is 600 kilohertz less than the transmit. So we talk about the offset, the transmit offset, as being minus 600 kilohertz. And if you're working through a repeater, it's important that you set the controls of your transceiver to listen on 145.725, but transmit on 145.125. That is for the St Austell repeater. Lots of other repeaters exist around the UK and indeed worldwide, and you need to look up the appropriate information for that repeater. So you can see there 145.125. Below that, I've written CT/CSS 77 Hz. This is a subaudible tone. Remember that 77 Hz is below the normal range of human hearing. But anyway, even if you have extraordinary ears and were able to hear that, it would be filtered out by the audio stages in your transceiver. So this tone is a way of telling the repeater to unsquelch and to trigger the transmitter to retransmit your signal. It's a sort of insurance policy in case any noise is around and it stops the repeater arbitrarily keying up and sending out a signal unnecessarily. Belts and braces, if you like. So there we have it then. The station on A presses the transmit button and he transmits on 145.125. The audio then comes out of the receiver, shown on the hilltop, follows the white arrow into the transmitter and comes out at 145.725. Why do we change frequency? Well, it's impossible to transmit and receive simultaneously on the same frequency, or it's very difficult to do that, because the transmit power would go into the receiver and we'd have feedback. So we have to have some filtering between the transmit and the receive to stop that happening. This is not a testable item. The testable item is that there is an offset and that it is 600 kilohertz. So there we are. In fact, I don't think you even have to know it's 600 kilohertz. There is a frequency offset that needs to be set into the transceiver. So there we have it then. And so once that conversation from A to B is complete, A will say over, and the situation will reverse. After a peep from the automatic circuitry in the receiver, B will then start his side of the conversation, and he will be transmitting on 145.125 and sending a 77 Hz CTCSS, and A will be listening on 145.725. And then when B is finished, he will say over, and you'll get this happening during the conversation. It will go back and forth like that. I should also say that that the CTCSS tone is repeater specific. So that is the correct tone for NC, North Cornwall, but other repeaters will use other frequencies for sub-audible tones. This is so that adjacent receivers, adjacent repeaters are not inadvertently keyed. Another part of the belts and braces, if you like. Now, the older way of getting a repeater to key was an audible tone of, I think, 1750, which was about sort of mid-hearing range, and that was sent off during the first part of the contact in order to get the repeater to kind of wake up and key. That is being phased out, but that is an alternative way of keying a repeater. And some people that are good whistlers can whistle to emulate that tone, and sometimes you hear people doing that. Right, so that's pretty much it on repeaters. Let's move on to another syllabus item. It says, recall that connecting anything other than the supplied microphone, e.g. packet radio TNCs, terminal node controllers, to the transmitter requires correct operation of the PTT, push-to-talk, line, and correct audio level signals. In the dotted box there, you've got a transceiver. It's got a transmitter and a receiver in it, and an aerial connection. And there's a microphone shown there, and the white arrow shows the audio going into the transmitter, and the red arrow is a press to talk. In other words, that's the button on the side of the microphone, which when you press it, makes the transmitter operate, keys the transmitter so that you emit RF out of your transceiver. Out of the receiver, the green line shows the incoming audio, if you're on in the receive mode, going to a speaker. So when you press the PTT button on the microphone, the transmitter keys, the audio goes through, and that would be an AM audio waveform that you might see at the coming out of the aerial. We wouldn't see it, but that's the representation of what you would be transmitting. Now, this is going a little bit further than what you need to know. This is giving you background to explain AD1. So when you release it, then you're on receive. When you transmit, you're back on transmit, and so it goes on. This happens, and because you have a foundation license and you've purchased the equipment, you can assume that with normal speech levels you won't overmodulate, or if you're using FM modulation, you won't overdeviate your transmitter, because the design of the off-the-shelf transceiver is such that the microphone and transmitter are set up not to overmodulate for normal speech levels. If you screamed down the microphone with it completely pressed against your lips, arguably you might be able to overmodulate, but in normal use you certainly wouldn't. And that's fine, because it relies on the fact that the output of the microphone is only so much. It isn't an infinitely variable amount of AC voltage you're going to get coming out of that. So if you use a terminal network terminal node controller, you're effectively replacing the microphone and speaker. So here we have the TNC plugged in to your transceiver, and the audio out of the TNC goes into the transmitter, and the PTT line comes out of the TNC, and out of the receiver you've got the green audio in going into the TNC. And connected to the TNC you will have a computer or a dumb terminal, in other words a screen and a keyboard, and the way this works is that you type characters on the screen. They're sent as data to the TNC, which turns them into audio tones, which sends them off to the transmitter, and any tones that you receive on the receiver are turned back into data and then displayed on your screen. So this is replacing the microphone and speaker with a TNC. And provided all the levels are set, then the transmit waveform will be a good healthy waveform, not over-modulated or over-deviated, and it might look like the one shown there on the screen. However, if the TNC level is too large, as shown by the thick white arrow there, and the mic gain is not adjusted on the transmitter, then you will over-deviate or over-modulate, as we've shown over-modulation of an AM waveform there. And that is a bad thing, and if you need to know why, have a look at the video on transmitters. So there we have an undesirable situation. So there are 2 points to take away here from your exam, for your exam. The PTT line is no longer then controlled by your thumb pressing a button on a microphone, and has to be automatically controlled by the TNC when it's got data that it needs to send. So that's the PTT line, and the audio out needs to be at the correct level so that you don't over-modulate the transmitter. So I think that covers most of the syllabus items, apart from looking at band plans. So you will get this booklet in the exam, the reference data for use in the foundation exam. And it is surprising how many people forget it's there, and therefore when they come across questions asking them about frequencies and band plans, or perhaps changing frequency to wavelength or whatever, are stumped. And all they've got to do is look on their desk and the answer's there. So don't forget that this is there in the exam. And it's called the X307. You can download it from the RSGB. This might be updated from time to time. Have a look for the latest version on the RSGB website. So here we have then foundation license parameters. Let's go through the X307 and see what we've got. Well, here we have one table here, which has got 4 columns, which is showing for the foundation license holder what frequencies bands he's allowed to use, the status of those bands in the UK, the status of those bands as applied to amateur satellite service, and the maximum peak envelope power level in watts, and also in brackets dB relative to 1 watt. Now for the foundation exam you do not need any understanding particularly of dBs, but you do need to be able to repeat this parrot fashion in a multi-choice, just in other words be able to look it up. So let's take an example there. Let's have a look at 3.5 to 3.8 megahertz there, and you can see that's the 1, 2, 3, 4, that's the 5th row down from the top, 3.5 to 3.8, and we know it's in megahertz because it says so at the column header. And it says primary shared with other services. In other words, it's mainly for amateur radio, but other services also share it. But the allocation is primary for amateur radio, and we're talking about terrestrial here. Can it be used with satellites? What's its status of allocations in the UK to the amateur satellite service? No, it's not allocated. And what is the peak envelope power? It's 10 watt, or expressed another way, 10 dBW. So those are the sort of questions that might come up. Look out for whether it's ERP or not. If you look at the top row there, they talk about 1 watt, 0 dBW, ERP, effective radiated power. So remember that that is the power applied to the antenna times the gain. But the main thing, I think, for the operating procedures part of it is to distinguish between 1 watt and 1 watt ERP in the multiple choice. Just look it up each time and run your finger over it carefully and repeat exactly what is there in the column. So a question might be, on what basis is 7.05 megahertz assigned to amateur satellite services? And would it be primary, not allocated, secondary, or I don't know, something else? So if you look down then, 7.050, you would find then is between 7 and 7.1. So that's the 1, 2, 3, 4, 5, 6th row down. And you move across to the third column and you see it would be primary. So that might be a possible question. If you look at the bottom row on the screen, 51 to 52, it might say what is the status of 51.5 megahertz in the UK, and is it primary, is it secondary on the basis of non-interference, is it etc, etc, etc. And you'd have to look in the second column, secondary, available on the basis of non-interference to other services inside or outside the UK. So that would be, for example, your answer. Having a look at another table on that EX307 handout, here we have, before we had the previous one, if I return to it, we had the allocations, and these are the allocations which you have to adhere to by law. And here we have a band plan. And why do we have band plans? We have band plans just so that we avoid chaos. So we know where to look for people sending similar types of signal to us so that we can reply to that similar type of signal. So if you're looking for telegraphy, in other words, Morse, and you're thinking you want to be in a contest, then you should be looking between 14 and 14.060 kilohertz. In other words, 14 megahertz to 14.060 megahertz. And the necessary bandwidth, 200 hertz. Contest preferred. And so if you look down there, you will see all sorts of different types of modes and the suggested places where you operate. There's a note on the right that says these band plans have been produced for exam use and are designed to be representative only. These band plans should not be used for on-air activity or as a guide to current practice. This is because the exam questions and the band plans that the RSGB produce, as I said before, tend to lag behind the updated band plans, etc. So there we are. There's the band plans. These are not legal requirements, but are almost, they're adopted almost with the same status by amateurs, and it's considered good practice to adhere to them and bad practice not to adhere to them. So there we go, that's band plans. And now that was 20 meters, that's an 14 megahertz, that's HF. Let's have a look here. We have some 2 meter band plans around 144 megahertz. These are VHF. And similarly, You can see the band plans there, and then the notes on the right. And for example, you might find that note 9, it says in other countries, IARU Region 1 recommended 145.375 MHz. So that then you would have to see what that applies to then in terms of the list on the left. So for example, 144.625 to 144.675 MHz says C note 10. And it says may be used for emergency communications and community events. So the notes then to the band plans are part of what you may be examined on. But again, you don't have to remember them. You just have to identify the frequency and look it up and see what it says. And then remember, it's multi-choice, so just pick the right one. So general band plan notes, these apply to all band plans. And an obvious one, it says for a given class of emission, the width of the frequency band which is just sufficient to ensure the transmission of information at the rate and quality required under specified conditions. So that's the definition of the necessary bandwidth. Once again, I would read these through. The one on beacons, for example, it says propagation beacon subbands are highlighted. Please avoid transmitting in them. So that's just something that may come up in a question. Once again, you don't need to learn all of these, of course. Nobody does. Therefore, reference during the exam, you just need to familiarize yourself with where they are so that you can have a good look and find out what you need to answer the question. The frequency and wavelength conversion chart we covered in frequencies and wavelengths video. Have a look at that if you are unsure how to convert frequency to wavelength and vice versa. And finally then, the allocation tables. Everything we've dealt with up until now in EX307 has related to the amateur service. Here it is showing where other services have allocated frequencies, and of course we're not allowed on those. So for example, if you look at 144 to 146, that's amateur and amateur satellite. Yes, we are allowed on that, but the band below us, 138 to 144, land mobile, we are not allowed on, and 146 to 149.9, mobile except aeronautical mobile, we're not allowed on that. So in that list there, we're only there once, the 2 meter band from 144 to 146, and the questions in the exam for this table, it might say where might you find radio astronomy, and they may give some examples, but you can see the frequencies there on the left, and the answer would be 150.05 MHz to 152.0 MHz. So that's it, EX307. I would urge you to have a jolly good look through that. Quite a long video this. I think it only accounts for 3 or 4 questions. So keep it simple and good luck. Thank you very much. And for the next video, we will be looking at safety.